So we have covered the concepts related to the inner products, namely the norm and orthogonality of a vector space. Okay, so we talked about complex vector spaces. All right, we talked about complex vector spaces. Complex vector spaces. What are complex vector spaces? Vector spaces in which the scalars are complex numbers. With the scalars are complex numbers. All right, and we defined an additional property in these vector spaces. That property was the inner product. Mind you that the definition of inner product doesn't come with the definition of the vector space. All right, the inner product has to be defined separately, and we can define it arbitrarily. In fact, we don't have to use the definition of the Euclidean inner product. There can be other definitions of inner product. Okay, for our purposes we will always use the Euclidean inner product that we defined before. So complex vector spaces that have an inner product defined on them, these types of vector spaces are called Hilbert spaces. All right, these are called Hilbert spaces. Okay, this is named after a famous German mathematician. His name was David Hilbert, who did many investigations on these types of vector spaces. All right, one thing to notice is that for finite dimensions, in finite dimensions, just having these two properties in finite dimensions, just having these two properties, complex vector spaces, this is property 1, and inner product property 2, just having these two properties we can define a Hilbert space. But for infinite dimensions we have to add a third property. We will not be using infinite dimensions in our course, but just for completeness I am stating that there is a mathematical property called Cauchy convergence. We again don't scratch your head too much on this. We won't be reading in this course, but just for your knowledge I am saying that in addition to these two properties, complex numbers and inner product, we need a third property to define a Hilbert space in infinite dimensions. For the purpose of for our purposes of quantum computing, just having these two properties, a complex vector space with an inner product, we can call that a Hilbert space.